Okay, let's start graphing linear patterns. First one I want to work on. So this is our first graph, but it's more than 3-1. It's also 3-2. I'm going to assign both one. They're both related. One's doing it by hand, the other one's doing it on a calculator, using your calculator. So let's see if we can get started. All right, my next slide. Okay, so here's our next slide. 3 ways to represent the following situation. All right, the 3 ways. The first one is using it as an equation. Here's our equation, and if you notice, it's ax plus b equals c. The a and the b are values that we're going to give you either in a word problem or just in the equation itself. If you notice, the a is attached to the variable x. That means you're going to that variable is what you're going to end up solving for, or you're going to substitute to find whatever you substitute for x is going to change whatever is your c. Your c was going to be replaced to your y, and if you put this in a calculator, it goes in your y1. So you can use your table and graphing on your calculator to solve these. Now, this may sound like a lot of gibberish, but let me tell you that the a in front of the x, that's going to be where you're going to look for a rate that varies. The b is your constant. What value stays the same? What do you start with? How much money did you begin your savings account? And then the a represents how much are you modifying it. This also is going to end up telling you your slope of the line, but we'll get into that later. That's jumping the gun just a bit. Okay, let's go on to our next slide. Okay, our next slide is actually giving us a word problem. The word problem is supposed to have $20 saved, and you add $2 to it each day. Well, that means we need to figure out where that 20 would go in the equation, and the $2 for each day. So the $2 is what's varying because it goes each day. You have to identify what your x is standing for, and in this case, it's days. We want to know how much she's earned in 1 day, how many in 2 days, how many 3 days, how many 4 days, and in fact, how many in 0 days, the day she started. Your y, or in this case, your c, is going to represent total cost, total saved. All right, so let's go on to the next slide. Okay, so on my next slide, 3 ways to represent the situation. Again, we're still in the equation format. So the x is talking about the days, so the 2 went in for the 2x. The days is representing the x. The 20 is how much she saved, and she started with it, so that's why the 2x is being added. It could also have been written y equals 20 plus 2x. All right. Next slide. Okay, so here's the table that's on your notes. They have the x equals d, and that d means for days. Here's your equation. And then again, this is the total. Y is actually how many dollars. Okay, I'm going to actually give you some numbers, and we're going to actually, and then we're going to plug them in, and we're going to solve them. So we're going to pick numbers and plug in, and you always want to show your work. Now you're used to doing the x and the y. The only thing different about this one is that we're going to have a show work column. we're going to actually show the work. Now your calculator could do all this for you. You put it in the y1 equals, and then you write 20 plus 2x, and your calculator will plug it. But you need to be able to do it by hand too. I want you comfortable doing it both ways. Excuse me. All right, so this one we're going to plug 0 in right here. Let me change my pen color. I'm not really liking this pen color too much. Let's change it to a darker shade. Let's go purple for a while. All right. So I solved this out. Get my pen. Let me erase that. Back to my pen. So that's going to be 20 because plus 0, because 2 times 0, see it's not even purple, 2 times 0, so this is 20. Now let's see if I can't get a blue. All right. Now I plug in the 1, so it's going to be 20 plus 2 times 1, and so it's 20 plus 2, and so in this case my answer is 22. Every time I substitute 1 for days, I get 22. So in 1 day, she'll have $22. All right, for question number 2, let me change my pen one more time because I didn't like that color. So now I have 20 plus 2 times 2. So that's 20 plus 4 equals 24. All right, now all of these end up being ordered pairs. The first one's going to be 0, 20. Second one is going to be 1, 22. And the third one will be 2, 24. All right. Now what we're going to do is actually graph these. So we're going to graph them on this chart. So my first one, if you remember, was 0, 20. So my x value is 0, and I go up to 20, and I make a dot right there. And then my next one is 1, and I go up to 22, and it's right there. Oops, it's selecting. There we go. And 2 was 24, and that's right there. It's amazing how I can't draw a dot. And if I collect them, do you notice how all those points, these are called, I'm drawing dots, but they're points, and all the points on the same line are called and then linear. They're cohabitating on the same line. So these are actually collinear. And if you notice, if you read it left to right, well, how's that line progressing? It's going up. So the slope is positive. And that makes sense because we were adding each day. If we were subtracting, what do you think would happen? Okay, so the first way we solve it is using the equation. The second way we solved it was creating a table. The third way was actually graphing. All right, let's go on to the next one. Okay, we're going to make a chart now, a table. We're going to do this again, but we're going to do it with a completely different set of values. Okay, so this one, remember, this is x. Those are all the values we're going to substitute, and they told us what to substitute. -2, 0, and 3. And then for in the middle here, this is where we're going to show our work. We're going to plug them into this equation, and our last one is going to be y. Now our x and y don't stand for words because we just have an equation. We don't have a word problem. So you could have also put this in y1 equals the -3x plus 4 and have your calculator do it, but you still need to know how to do it by hand because you get non-calculator tests. So the first one, I'm going to substitute, instead of using x, I'm going to put -2, substituted. and plus 4. So negative 2 times negative 3 is not a negative, let me erase that, but a positive 6 plus 4, so this will be 10. The next one I'm going to put negative 3 times 0 plus 4, and that creates 0 plus 4. When I substitute 0 for x, I get the answer 4. And then negative 3 times 3 plus 4, that's a negative 6 plus 4. No, not negative 6. What is it? All right, so we're going to graph those. So negative 2, 10. So negative 2 and up 10, that's right here. 0, 4. So I don't go 0, I go up 4. And the last one is 3, 1, 2, 3. Negative 5 all the way down here. And then best I can, let's connect those. All right, looks good. Now look at this one. In this equation, we're actually going decreasing. If you're looking from left to right, we have a negative slope. So it's going downhill. All right, let's go to another one. Okay, now the question is, I lost all my graphing. With negative 2, is 2, negative 1 a solution? Well, we plug it into our equation. We put negative 1 in for y equals negative 3 times a positive 2 plus 4. Well, negative 3 times 2 is a negative 6 plus 4, and that gives us a negative 1 equals a negative 2, so they are not solutions. That's how you prove it. You will have to do that on a quiz one day. All right, the next slide. Okay. The next slide is the constant increase. This is not on your sheet. You will need to add this to your sheet. But as you look at the tables, you want to know if it's a constant increase or constant decrease. Well, how you know is if you're adding or you're subtracting. It's an increase in the table. When you're reading the graph, it goes uphill from left to right, and you're adding the same amount every time period. It's a positive number. A decrease, which is, by the way, this increasing is called a positive slope. And then the decreasing in table, downhill from left to right, you're subtracting the same way, that would be a negative slope. All right, we're going to do the homework tomorrow in class. I'm going to answer any questions. This is the first time I've actually done this, so I'm pretty sure there's going to be a lot of questions. All right, let's see if this works.